Hello everyone, and welcome back to this second video dedicated to the FCC reaction section. We saw in the first video that we had 4 different sections in the FCC process. And we said that we would detail 3 of these 4 sections in this first series of videos. But before going into the details of these 3 sections together, let's have a look at the feed and its characteristics. As we have seen together in the previous video, the feed comes from the vacuum distillation. In fact, other types of feed can be treated in an FCC, but in these videos we will focus on the feed produced in a vacuum distillation unit that we call VGO for vacuum gas oil. In a vacuum distillation, the pressure is reduced down to 50 to 100 millimeters of mercury. It means about 100 millibars absolute. Reducing the pressure makes it possible to vaporize molecules that could not have been vaporized at atmospheric pressure. Generally speaking, a vacuum distillation furnace operates at an outlet temperature ranging from 380 to 400 degrees C, and sometimes even more. That makes it possible to reach VGO vacuum residue cut point of 540 to 580 degrees C. As a reminder, a light vacuum gas oil is produced at the top of the vacuum distillation. This cut will be a very good material to produce domestic fuel. For the rest of these videos, I suggest we focus on a VGO feed with a boiling range of 375 to 550 degrees C, since it is a typical VGO distillation range in a conventional vacuum distillation. With such a boiling range, we see that for North Sea crude, the VGO cut represents about 20% by weight of the crude. This is called the VGO yield of a crude. Depending on the crude, this VGO yield varies between 15 and 30%, with an average value of about 23%. However, this quantity tends to be higher for high sulfur crude rather than for low sulfur crudes. Indeed, low sulfur crudes present an average VGO yield of about 21%, whereas the high sulfur crudes present a VGO yield of about 26%. With regard to the sulfur content of the VGO, it is closely related to that of the crude. As we clearly see on this graph, the higher the crude sulfur, the higher the associated VGO sulfur. On an average, a low sulfur VGO has 1.7 times more sulfur than the associated crude. This value is lower at about 1.25 times for a high sulfur VGO. Thus, a low sulfur VGO has about 0.3 weight% sulfur, whereas the high sulfur VGO is about 2% by weight. The sulfur content has a direct impact on the sulfur content of the FCC product, but also on the SOx concentration in the flue gas leaving the regenerator and then released to the atmosphere. For nitrogen, because we will see that this is important for the FCC process, it is extremely variable. We can see that, on an average, the nitrogen content in the VGO is about 1.4 times that of the associated crude. But this figure ranges from 0.7 to 3.5 times. It should be noted that a VGO has a nitrogen content of about 1,500 ppm by weight. The nitrogen content impacts the conversion in the FCC. In fact, the higher the nitrogen in the feed, the lower the conversion will be. Regarding the density of the VGO, it does not depend that much on the density of the associated crude. The density of a typical VGO varies between 900 and 940 kg per cubic meter. Density is important for the FCC process. Indeed, a feed with a low density is rather favorable to cracking, whereas a feed having a high density will be more refractory to cracking. If we summarize, here are the important feed properties for the FCC process. The yield, the sulfur content, the nitrogen content, and the density are recalled. Note that the metal content in the feed is also important. For a typical video with a vacuum distillation which works pretty well, the video metal content is about few ppm. When we talk about metals, we mainly target nickel and vanadium. Note that these two metals are catalyst poisons. That's why we need to monitor them and control them carefully. It is also to be pointed out that some other metals, like the iron, are also catalyst poisons. Finally, the last property on which we can focus is the carbon condensate. This value reflects the tendency of the feed to produce coke. For a video produced in a vacuum distillation, this value is low, less than 1% by weight. As a note, there are some FCCs that treat vacuum residue as an additional feed. For vacuum residue, this carbon condensate value can go up to 5% by weight, and the metal content is multiplied by 10 compared to that of the video. Once the vacuum distillation has produced its VGO, it is generally stored in a tank at a temperature of about 70 to 80 degrees C, so that it does not solidify and remains in liquid form. Our feed is now ready for cracking, so see you in the third video to discuss the FCC process. Well, that's it for the second part. I invite you to test your knowledge by answering the quiz whose link is available in the description of the video. In the meantime, do not hesitate to subscribe to my YouTube channel. Refining is exciting. Thank you very much for your attention and see you very soon for the third part. Bye bye!